So now instead of assuming that the lines are parallel and then identifying that corresponding angles then are equal, this is the opposite of that, just the converse of that. So now it's going to take if your corresponding angles are equal, then the conclusion is that the lines must be parallel. Right, so looking at this example right here, it's saying if the measure of angle 2 is equal to the measure of angle 6, then J is parallel to K. So that is the conclusion here. Okay, so the converse is used, the converse of all of these proofs is going to be used to demonstrate that lines are parallel. Okay, the original statement is taking that, then finding the angle pairings that are equal. And so I'm going to talk through the first one, have you do the second one for each of these examples here. When you use this, or when we get to proofs with parallel lines, which is going to come at the second half of this section, we will use the same acronym for both the original statement and its converse. So corresponding angle CA will be used for both. The idea is that the context of what it is, what conclusion you're drawing is going to be what determines whether it's the converse or not. But when you identify it, you're just looking for the acronym for corresponding angles. And so if we look at this first example right here, in these types of questions where you're asking to identify what would a variable or an angle measure have to be in order for the lines to be parallel. Okay, so if you have this relationship here, if you know that angle 2 is given by the expression 8x plus 10, and you're told that the measure of angle 4 is given by the expression 9x minus 6. Okay, what would x have to be in this case is what it's asking in order for these lines to be parallel, and that would occur if these corresponding angles, which when you look at how are these angles related to each other, they're on the same side of the transversal, one in the interior, one in the exterior. That means they're corresponding angles. And so they have to be the same, and you would take those expressions, set them equal to each other, and this is going to give you the lines that are parallel. So if we solve for x here, move all the x's to one side, so subtract 8x from both sides, move all the constants to one side, so we add 6 to both sides, we get 16 is equal to x. Just double check, is it asking you to find the value of x, or is it asking you to evaluate the function? In this case, it's asking us to just find the value of x. If it had asked you here instead, what is the measure of angle either 2 or 4, then you would take that value of x and you would substitute it in. So if you had a problem like this, you would get 138 as your angle 2. But again, it's asking you for x, or is it asking you for the angle? So I want you to try the next problem over. See if you can answer that in a similar fashion. Okay. What would the value, or what would the angles be in order for those two lines to be parallel? The relationships for these angle pairings that we're looking at is corresponding angles are equal, same side, or the alternate interior angles are equal, alternate exterior angles are equal, and when it comes to the same side interior or the consecutive interior angles, those are the ones that are different. Those are supplementary when you're dealing with parallel lines and the angles formed there. Right, so in this problem, first a couple of things. You see that you're solving for an angle. So it's not just the x, you have to go that one extra step after you solve for x. But if you have angle 5 and angle 7, and you look here, angle 5, angle 7, they're on the same side of the transversal, one in the interior, one in the exterior. So these are corresponding angles. And corresponding angles have to be equal in order for the lines to be parallel. So if we take those expressions, angle 5 is given by 3x plus 12. Set it equal to the expression for angle 7, which is given as 11x minus 4. And we solve for x. So if we put all the x's on one side, move our constants to the other side, we get 16 is equal to 8x. Divide by 8, and we get x is equal to 2. So remember, do not put that in. That's not your answer. Your answer is 5x, which is 3 times some value x plus 12. If you get your x value to be 2 and plug it in, that will be your solution. So you could either enter it as a calculation, or if you calculate this, 3 times 2 is 6, plus 12 is 18. So those would be your options for entering that solution. Right, so what we're going to see here is that these relationships that we looked at from the original form, when you're given that lines are parallel, then these are the relationships. Now we're just taking the converse for each. So the next one is alternate interior angles. So this converse states that if your alternate interior angles formed when two lines are intersected by a transversal are equal or congruent, then that means the lines are parallel. Okay, so that's the symbol for parallel. Once again, this is alternate interior angles, and so when we justify this converse, we're also going to use AIA, okay? But this is the converse of that. And so once again, coming down to the example below, we're looking for x. Okay, we're given angle 3 and angle 6. When we look at angle 3 and angle 6 here, they're on opposite sides of the transversal, both in the interior. So those are AIA, which means that they're equal to each other. And so again, if we take the expressions, angle 6 is 8x minus 5. Angle 3 is 4x plus 12. Set those equal to each other. Move all our x's to one side, move our constants to the other. And when we solve for this, we get 4x is equal to 17. Divide by 4. And that is our answer. Again, we're only being asked to find what x is. 17/4. If you looked at the decimal equivalent to that. All right, so getting specific to approaching these questions, I've tried to put the answer prompt in the question. If I notice that I haven't, I'll try to remember to add that. But when you look at the answer prompt, you see you are trying to find angle 3 here. Well, that automatically means if you go up and look, angle 3 is 9 times x plus 4. So if you begin like this, enter this into your answer field before you start. This will help encourage you. Don't just stop at x. You're going to find x and then plug that in. Okay, and so the angles that are involved here are angle 3 and angle 6. Once again, angles 3 and 6, the same alternate interior angles, so AIA. And so in order for these lines to be parallel, you need the alternate interior angles to be equal. So if we take the expression 9x plus 4, set it equal to 12x minus 6, and solve the resulting value for x, move the x's to one side, constants to the other, you get 10 is equal to 3. X divide by 3. And so there is your value for x is 10/3. And if you type that directly in, you'll get your answer. Now, if you are simplifying this by hand, 3 goes into 9 3 times. 10 plus 4, which is 34. The calculation will show that same number as well. So you can enter the calculation or the calculated value. Either one is fine. All right, so we looked at CA, corresponding angles. We looked at AIA, alternate interior angles. The next is AEA, alternate exterior angles. And so the relationship is if you have alternate exterior angle pairs that are congruent, then the lines they intersect are parallel. And this is AEA. So remember, this stands for both the original relationship and the converse. And so if we look at this first example, we're finding x. So to find x, we look at angle 8 and angle 1. These are on opposite sides of the transversal, both in the exterior. So these are A, EA, which means if we set them equal to each other, 3x plus 10, set that equal to 11x minus 5, solve the resulting equation for x, and that's our answer. Move the x's to one side, the constants to the other side. And we get 15 is equal to 8x, divide by 8, and there is our answer, 15 over 8. If we type that in, it should display the decimal equivalent, 1.875. Now notice, even though this said to the nearest hundredth, if we add, or if we extend it to one more decimal place to the right, it is the exact answer instead of an approximate answer. I always prefer exact answers. And so if it's something that I can easily enter the decimal form that's an exact answer, I do prefer that. Anything else, you can round it. But again, the ideal answer is the exact one, which is written as a fraction or written as a terminating decimal. All right, try this second one here on your own. All right, so here we're looking for angle 8. Angle 8 and angle 1 are involved in this, same set of alternate exterior angles. Angle 8 is given by the expression 3 times x plus 6. So I'm going to use that as sort of as a template. Fill that in. The x is my placeholder, so I need to go in and solve for x. Angles 1 and 8 are alternate exterior angles, so they're equal. So I can take the expressions 3x plus 6 set equal to 5x minus 8 and solve the resulting equation. Move the x's to one side, the constants to the other. I get 14 is equal to 2x, divide by 2. I get x to be 7. There's my value of x. I plug that in. 3 times 7 is 21, plus 6 is 27. And so I can enter my answer as a calculation or the calculated value. Right. The final problem here, the final relationship has to do with consecutive interior angles. Now again, the relationship that happens for these same side interior or consecutive interior angles, in order for the lines to be parallel here, those have to be supplementary, not equal. Okay, and so here it's saying that if measure of angle 3 plus measure of angle 5 is equal to 180, then then line J is parallel to line K. So CIA or SSI is what you'll see for these. So I want you to answer both those questions on the bottom using this relationship, please. Again, here it's a matter of looking at your answer prompt. It wants the x. So we're looking for angles 2 and 3. These are on the same side of the transversal, both in the interior. So these are consecutive interior angles, or CIA, same side interior angles. So that means that we're going to take their expressions, 3x plus 11 and 9x minus 5. We're going to add those together and set them equal to 180. Okay, so CIA or SSI are supplementary angle pairs in order for the lines to be parallel. And so if we combine our like terms here, we get 12x plus 6 equals 180. Subtract 6 from both sides. We get 12x is equal to 174. Divide by 12. And here, when you divide by this, you can leave your answer in this form. You can answer 174 over 12. It still will calculate that, so it doesn't necessarily have to be reduced down. If you did reduce it, like more than likely next year, if you don't, in your math classes, oftentimes the fractions will need to be simplified into their reduced form. That would be 29 over 2. And the decimal equivalent would be 14.5 for these. And so either of any of those forms here would be acceptable answers. And if you catch yourself making mistakes, again, you want to enter your answer in the form that's the least likely to make a mistake. And so that improper fraction 174 over 12 is probably the ideal number to use for that. All right, the last example here, we have when we're finding two angles, angle 6 and angle 7. So based on those, we see that these are also consecutive interior angles, or same side interior angles. So they're going to be supplementary. So 3x plus 8 added to 11x minus 6 is going to equal a supplementary measure 180. And so here, when you combine what you have, you get 14x plus 2 is equal to 180. Isolate the x's, so we subtract 2 from both sides and divide by 14. So once again, same thing, right? You can leave your answer in this fraction form. Angle 6 is 3 times x plus 8. Angle 7 is 11 times x minus 6. Again, not a bad place to start if you catch yourself making the mistake of entering x's when you're supposed to be entering the angle measure. And then we can just plug in that 178 over 14 in there. Now, again, if you wanted to, you could reduce this and get 89 over 7. So you could have entered 89 over 7 here as well. But either one is fine, and it would give you your decimal equivalents. You could also enter those, calculate those on a calculator, and then enter the rounded form. Now, this is the case where, because 89 over 7 is not a terminating decimal, okay, it continues for a while, that you could round this to the nearest hundredth. Remember, the one thing that should not happen is do not take this value right here and get 12.71429 approximately. Okay, do not round this to 12.71 and enter it here. You can't enter rounded values when you are evaluating. Okay? Anytime you evaluate, you need to evaluate with the exact number. Okay, and then the rounding happens only when you enter your final calculated form. Okay, so you can't round in the numbers that you insert to evaluate. You can only round when you take your final answer.